Hello, good afternoon to all architects, engineers, students of architecture, civil engineering, also to the audience other than architecture and civil engineering. We welcome you to a very unique seminar where Sir J.J. College of Architecture, a premier architecture institute, along with KONBAC, a institute that works in bamboo promotion as a construction material to design new buildings, has taken it upon themselves to let you know first about the bamboo as a material to work with, and then it to be used as a very strong structural material to be able to let architects and engineers know that they can become a very important design element while doing buildings and structures. So we will first introduce to you the galaxy of speakers that we have been blessed with, who will interact with you one by one. And before I let you know about them one by one, I would like to begin by introducing myself. I am an architect and an urban planner. I have been teaching for last 27 years. I have been in the process of teaching subjects related to urban planning, urban design, architecture design, and design dissertation. And we find alternative use of building material as a very unique and a new prosperous way of designing buildings because it has to be ecologically efficient, environmentally relevant, so that we can do wonders in our environment. Let me begin by telling you about the Konkan Bamboo and Cane Development Center, which is running under Sanjeev Karpe. Konkan Bamboo and Cane Development Center is a Section 25 not for profit company set up in 2004, facilitated by International Network of Bamboo and Ratan through the Center for Indian Bamboo Resource and Technology, CIBAT, as one of the INBAR's Action Research Sites, ARS. KONBAC focuses activities on the development of bamboo as a key resource for catalyzing an inclusive green economy. Over the last 16 years, KONBAC has made considerable progress in growing into a self-sustaining institutional ecosystem and has a fully developed facility for designing, prototyping, and productionizing marketable bamboo products for Indian and international markets. It has also put in place certain mechanisms to link poor bamboo producers to larger lucrative markets and has emerged as a model that is being emulated elsewhere in India and abroad. This expansive and intensive work put into achieving of growth has also led to areas of expertise within the organization and innovation. One of the key strategies pursued by Konback was to work towards positioning bamboo as a pro-poor, I repeat, pro-poor, credible alternative to timber, providing the rural poor and small landholders an opportunity to participate in and benefit from the US dollar 100 plus billion wood products market. A second important strategy developed was to let bamboo's off-farm economic value and opportunity to realize the considerable environmental benefits that its growing offers. Konback has succeeded in changing the perception of bamboo from being a poor man's timber to a rich man's choice as a credible alternative material of high quality wood that is currently being used for furniture and construction very successfully. Industrial design centers from IIT Bombay and IIT Delhi have been using it as an academic learning resource. They go to Northeast and actually practically implement these ideas, which has helped move bamboo up the value ladder and as a material of choice for the environmentally conscious community and for those consumers who want innovation and novelty. Konback has developed a blueprint to transfer and disseminate its replicable model to new locations across the country and develop an entire product line of furniture, craft, and prefabricated building construction components. Thereby, creating a holistic ecosystem of supply of high quality bamboo products in the country. This will not only generate new business opportunities, but also motivate investment among people who produce bamboo. They can also define clear rules for both purchasers and sellers and encourage institutions to develop many enterprises. KONBAC envisions the growth of a dynamic bamboo industry that catalyzes an inclusive green economy globally. So it is not to be seen as a local economic development, but also to look at it globally. This brief introduction would let you know how important KONBAC has been playing its role in not only promoting bamboo as a building material, but also utilizing it in the building construction. I would now take this opportunity to introduce to you galaxy of speakers whom we are very fortunate to have. We have Mr. Abhay Gandhe, who is head of agriculture at Tata Trust. He's Masters of Science, a senior development sector professional, having core competencies in agriculture and natural resources. His experience in delivering science and technology solutions to farmers through agriculture and rural development projects in India are well known. Tata Trust is amongst the India's oldest and almost well known non-sectarian philanthropic organization. The trust owns two-thirds of the stock holding of Tata Sons, the apex company of the Tata Group of companies. The wealth that accrues from this asset supports an assortment of causes, various benefits, institutions, and individuals in a wide variety of areas. This way, the profits of Tata companies earned go back many times over to the communities they operate in. The funds have been developed, deployed towards community development programs across the country for over 100 years now. And Tata Company is actually known more for community development projects as a successful industry more than the success they already enjoy by their products which they manufacture. We are also going to be joined by the office of Shift, which is owned by Sanjay Prakash, a well known architect who believes in energy efficient and ecologically efficient building construction. And from this office, we are having our alumni architect, Mayank Mishra, who will be actually presenting this project. He is a principal architect in Shift and an expertise in sustainable design and ecological sensitive design with collaborative approach to design is his forte. Branding and product design is also what he loves doing. Being an alumnus of prestigious Sir J.J. College of Architecture, Mayank naturally adopted the role of principal architect with Shift, which is a boutique collaborative practice working mainly in the field of sustainable architecture. Being able to simultaneously lead the various processes that Shift, Mayank works with a creative research and analytical thinking. He exhibits leadership as well as managerial skills while maintaining the core role as a doer. Known to be creative, naturally because he is our student, he also exhibits great understanding and brings to bear a high degree of concentration on his work. Sustainable campus design, green office buildings, master planning, eco resorts are some of the well known real estate projects on which he has already worked. Water management systems, energy cycle, life cycle are examples that Mayank deals in its specialization. Will be then followed by a talk from Dr. Abhay Gupta, who is a civil engineer since 1981, and then he also did his ME structures from Indore, SGSITS, and PhD from University of Roorkee in 1996. His specialization area was aerodynamic interference in tall rectangular buildings, wind tunnel studies. He has more than 35 years of experience in the field of civil engineering, construction, and structural design, and also teaching research with several academic research and development institutions and Bureau of Indian Standards. He was also the principal consultant for establishment of India's first international state-of-art wind engineering application center in private sector for tall buildings and structures. Also for Jayaprakash Associates Limited at Guna in MP, which is one of the country's biggest wind tunnel facility for building structure. We welcome you all three for this webinar, sir. It is now my turn to let you know about Mr. Krunal Negandhi, who is a director at Jans Bamboo Products Private Limited, Thane. Krunal is also a qualified civil engineer and has a diploma in construction technology and a certificate in environment quality management system from Bombay University. He is ISO 9001 lead auditor and CII certified sustainability assessor. As a sustainability professional, he has given shape to projects such as Lavasa, the largest greenfield city in India. He is also co-founder and director of JANS, Bamboo Products Private Limited, India's premier bamboo construction and furniture company. Sanjeev Karpe, of course, who is our collaborator from KONBAC and the owner, is an electrical engineer by training. Sanjeev is committed to putting bamboo and positioning it as a key resource for catalyzing a green economy and generating rural livelihoods in India. A Prerna Fellow from IIM Lucknow, he has been associated with the bamboo industry for the last 16 years. He is a pioneer in the field of manufacture of premium bamboo products in India. He has established a full-fledged ecosystem, including infrastructure, human resources, to build capacity of bamboo farmers. He is founder and managing director of Native KONBAC Bamboo Products Private Limited, a Sankalp award-winning enterprise. Also the director of the Center for Indian Bamboo Resource and Technology. He has had a very successful story already in his experienced career as a bamboo expert. He is an expert member of the steering committee of the task force on bamboo construction and the chairman for modular bamboo furniture cluster Sindhudurg, a project which is actually supported by the Directorate of Industries, Government of Maharashtra. Besides this, we have very interesting two speakers from the government, and I am extremely happy to let you know that one of them is a structural engineer who is an Indian Forest Services officer who is working in a very dynamic way and was involved in this project which Mayank from Shift will actually present. And he is S.V. Ramarao. During 2003 to 2007, as Defense Vatsa Gadchiroli district provided employment to needy people under MG Rega, which is Mahatma Gandhi National Employment Guarantee Scheme and Authority, and created more than 250 forest tanks. Once upon a time, there were no tigers in Vatsa division. Now it has become a place for 16 tigers. During 2011 to 2014, as an achievement, Gondia rehabilitated 5 villages from Navigaon National Park, and also everybody got settled in a newly constructed village with all amenities just adjoining to Nagpur Raipur National Highway, all under his guidance and work. As conservator of forest between 2014 and 2016, Wildlife developed an innovative protection mechanism to stop encroachment in Yaval Sanctuary in Jalgaon district, and he has taken efforts to rejuvenate the sanctuary. Due to the special protection mechanism adopted, tigers not seen in the last 20 years are now seen back in this sanctuary now. Tiger saving or tiger safety has been a very important project. Even today, the chief minister does not want the railway line to go through the Melghat forest, and due courage and work is required to take care of it. When it comes to the awards received by him, he is a university first in civil engineering from Nagarjuna University. He has received a gold medal for work plan preparation during training at IGNFA. Dehradun, which I think is a national center for forest officers. He received the silver medal through hands of Honorable CM Maharashtra in 2014 for better protection and management of forests. And he has received civil services honor in the year 2018 through the hands of the Honorable Finance Minister Maharashtra. The last person which I am going to let you know about is a chief engineer from government of Maharashtra PWD department. Ulas Debadwar is a no nonsense dynamic officer, civil engineer, who has made a special development in all matters related to all kinds of work. I was indeed privileged, and as a matter of great honor, I had an opportunity to work with him when he was a superintendent engineer posted in Bombay at Bankam Bhavan. And I had a privilege of working with him, learned a lot from him. And I am very happy to know that as a chief engineer in Nagpur, lot of work must have happened during his tenure. He was a key person who was responsible for the development of the projects here. Now, after having introduced all the key speakers and all the people who are going to make a difference today in our project, we will actually let you know the flow of events. Okay, I would welcome the first speaker to address today, and he is Sri Abhay Gande, who is the head special projects agriculture from the Tata Trust. I welcome you, Sri Abhay Gande, to make your presentation and a talk to our audience.
Okay. Namaste and greetings to everybody from Tata Trust. I hope I'm audible to everyone, right?
Yes, sir. I would
So,
like the audience to know that if there is anything that you wish us to know, you can use the chat button on the screen. We will let you get answers to your question after all the speakers have presented and made a presentation. Thank you very much. Yes, Gande sir.
yeah. So, uh, greetings from Tata Trust to everyone. I don't have a special presentation for this event, but it's going to tell you exactly what is the correlation of Tata Trust with this bamboo architecture that is happening in Chandrapur district through BRTC. So Tata Trust is a philanthropic organization committed to cause of rural development, livelihood development in rural areas of India. Since about 5 years, Tata Trust is committed to bamboo resource development. We have launched a series of projects through NGO connections in Maharashtra, in Uttar Pradesh, in some parts of Madhya Pradesh for developing bamboo value chains. Now, during the course of this bamboo program development, the government of Maharashtra uh, approached Tata Trust to think about some big uh, structure that can be developed in Maharashtra to demonstrate that okay, bamboo as a construction material, bamboo as a housing material has a scope. Otherwise, what was happening was all over the world, so many structures were developing, but bamboo in Maharashtra was getting used only for small scale uh, structures here and there. There was no convincing proof of one mega structure that can demonstrate suitability of bamboo as a construction material. So, as those discussions progressed, uh, we quickly realized that what can be done is some real big structure which requires some totally non-conventional thinking, but can be done in within the state of Maharashtra through the joint efforts of Forest Department and PWD, and that can become a landmark proof of usefulness of bamboo in construction program. So the place that was decided was Chichpalli in Chandrapur, where forest department has a strong presence. And when we progressed on deciding what can be done, we realized that there could be lots of gaps in executing this as a project because this is going to be a daringly different project was the understanding there. So one of the gaps which was identified during the course of planning was to access inputs of a technical agency for guiding this project properly, for keeping it on track. And the unique agency that exists in India for doing this kind of work on bamboo or renewable materials in construction is this agency of Shift Studio for Habitats based out of Delhi, headed by Sanjay Prakash. So this agency was recruited uh, as a advisory agency for this project. They are based out of Delhi. So what Tata Trust did was to discount the costs and the procedures of their operations because otherwise through the government procedures it would have taken a long route and a long time to get them on board. So Tata Trust, as a part of their philanthropic mechanism, discounted the costs as well as the procedural time for onboarding them, for onboarding Shift into this project. So that was one major contribution from Tata Trust. And sequentially, over a period of time, whenever it was a requirement of some joint action, Tata Trust has worked with the government departments, with KONBAC, with all other stakeholders to ensure that this project is on track. Now, through this gap funding mechanism, Tata Trust has plugged in a gap which is very critical for the project. The inputs that have come from Shift repeatedly over time have definitely added a great value to this building, which is now nearly completed. Uh, with the Shift, we have completed the first phase of contract for this project. The second phase of contract with Shift is now nearly over. We are in the process of completing the tail ends of the contract so that by the time this structure is completed, the inputs of Shift should have ensured a perfect bamboo architectural structure that demonstrates suitability of bamboo as construction material in India. And one unique characteristic of this project, which I want to highlight, is that the bamboo that is used in this project is all Indian bamboo. Because conventionally, everyone was thinking that the bamboo which is available in China, bamboo available in the Southeast Asia is better for construction. That is the only way out when you go for a larger structure. But this structure of BRTC that is coming up in Chandrapur definitely demonstrates that the Indian bamboo also is equally suitable for such kind of mega structures. So this is something which the government of Maharashtra and Tata Trust and KONBAC have jointly done together, something which is daringly different and which is now almost complete. So it's a proof that by collaborating across the sectors, this model, which can be said as a PPE model, has worked wonders, has delivered. So this is all from me from Tata Trust. Thank you.
Thank you, Gandhi sir. Thank you very much for your inputs. I would now request Sri S.V. Ramarao to come in and offer his comments and offer his expertise. The audience who wish to ask questions to Gandhi sir, may please keep it in record. We will get back to you after the presentations of all the experts. Thank you. Welcome, Ramarao.
Good afternoon to the organizers, co-speakers, participants, and the viewers. Probably I am the only person who is in the middle of the balance because I have seen both sides. I am an MTech structural engineering by qualification and working as a forest officer in the capacity of chief conservator of forest. In the beginning, I would like to say a few words about the raw materials. This bamboo is unlike other building construction materials. It is a renewable material. Other materials like whatever it is, steel or cement, whatever it is, the other materials are not renewable. They destroy some, we destroy something and generate these materials. But whereas the bamboo is concerned, it is a renewable, regenerable material. You can get after every 3 years this material. So it's there is no destruction of anything, any such sorts of things. So right now I am working in Chandrapur and Gadchiroli district, which is known for high dense forests. The capacity or the productivity of these areas alone is almost 2 lakh metric tons. 2 lakh metric tons bamboo is being produced in Gadchiroli and Chandrapur. This is the capacity of these two districts. If you see likewise in the whole Vidarbha, most probably around 5 lakh metric tons is the real capacity of these forests. And this is being abundantly grown in the forest and even outside the forest also. So overall, we have a net productivity of 5 lakh metric tons in these Vidarbha forests and non-forests. Now, if you see the uses, previously we used to use this bamboo for some agriculture implements, or for manufacturing of paper, or for as a supporting structure for the grape and these orange gardens, and all those traditional usages. Now, gone are those days. Now we are thinking even a step forward. We now things have come up. Bamboo is being used in furniture making. Bamboo is being used in some other sophisticated articles. Now the bamboo has come to the construction wing also. Now this is the crucial juncture where if it is tested beyond doubt that bamboo can be used as a good construction material, I think the sky is the limit. There is no limit for bamboo usage in the construction sector because it is this juncture, it is the right point where we should think of bamboo, whether it can work as a substitute to the RCC or even the metal itself. So bamboo is now abundantly available everywhere. It can be grown everywhere. So now we should see whether this can be a substitute to the other materials. Maharashtra, being a pioneer in several forest development projects, has started forming a Maharashtra Bamboo Development Board in 2016, and we have started a bamboo research training center in Chandrapur as a headquarter run by an IFS officer, Mr. Rahul Patil, in Chandrapur. And the BRTC is meant for Bamboo Research and Training Center. It will look towards research and some training aspects also. So now we wanted to have our own building for BRTC. While thinking so, the government of Maharashtra has thought of having a bamboo structure with the help of the PW department and the Jans Bamboo and SWIFT as a consultant and Tata Trust as a facilitator. We thought of having a bamboo based building for our own BRTC. The name itself is BRTC, and going for a concrete structure doesn't have any sense. So we thought of having a bamboo based structure. So I'm the construction in charge, chief in charge of this BRTC structure being built at Chichpalli and Chandrapur districts. The total cost project is around 91 crores roughly, and almost the construction is completed. Maybe in a month or so, it will be available for usage. And one good thing is I would like to highlight this. Very recently, our head of the forest forces, Mr. Gairola, had visited Chandrapur, and he had seen three different structures built by PWD for the forest department. Two of them are concrete structures. One is this bamboo structure. The moment he has seen this bamboo structure, he really appreciated because he was very much impressed by this bamboo structure, and he had voted for the bamboo structure. He said this is the better of all the three. That was the beauty of this bamboo structure. And as a structural engineer and as a forest officer also, when I have seen this construction from a close angle, I thought I should bring certain facts before this. See, the advantages is for using bamboo as a construction material. Definitely, it is a renewable material. It can be regenerated very easily, eco-friendly, and it cools down the temperature also. If you see the temperature within that structure and outside the area, almost 2 degrees difference will be there. And if it is tested beyond doubt, then it can be used very massively. But certain negative points are also there. First of all, we don't have any past history of these bamboo structures. There is nothing to compare with other structures. Everything is new. We have to think new. We have to start new. We have to design the things new. There is no past testing histories. Yeah, okay, there is no standard codes available for this. We have a sufficiently legally available codes for the RC structures and metal structures, but there is no proper codes available for even bamboo structures, and it requires very highly skilled manpower, and very difficult to make a give a technical sanction because there are no proper DSR rates available for these structures. And right now the cost effectiveness is also very low because things are very new, and the cost is also compared to other structures little high. And as we progress and the work is going on, unexpected unforeseen happens very fast in a RCC structure. And this metal structures, everything is pre-designed. There won't be much change as we proceed. But in a bamboo based structures, many if and buts happens. Many things have to be changed. All the things cannot be thought of in the beginning itself because there is much uncertainty is there. Apart from all these things, if we come to a conclusion that bamboo is a magic material, like 50 60 years back we were not having cement, RCC, reinforced cement concrete was not there. When we found that reinforced cement concrete is a magic material, can be used for a construction material, when it is found tested for its compressive strength or tensile strength or even its shear strength or torsion, whatever it is, for all kinds of testings, for its fireproofingness and for its durability, for its cost effectiveness, when it was tested, it was treated as a magic material. We always call it as a magic material in our college days. When RCC was found to be a magic material, we have seen the revolution in the construction field in the last 50 60 years. Starting from a small construction of a small house, we have gone up to aerodromes and all different big structures all over the world. So that was the revolution that RCC has brought up in the construction field. Now, can we think in the similar lines with the bamboo? Now, can we say with 100% probability, yes, our bamboo can also be a big construction material which can have sufficiently reasonable strengths of all the reasonable qualities of all the RCC or metal structure, whatever it has. Of course, bamboo being a biological material, it has its own limitations. But beyond that, can we think, or can we do some research, or can we do some testings, or can we do some kind of thing so that it can be said that bamboo can be a construction material beyond doubt? Then I think bamboo can be one more magic material in the history of construction, because bamboo can be used as a local material. The real challenges what we are facing in bamboo construction right now is the fireproofness. Whether it is really a fireproof material, that has not been tested so far. We assume that it will be a fireproof. We are doing some fireproofing mechanism, but is not tested yet, because in Chandrapur the temperature sometimes goes to 48 degrees, 49 degrees. Can it be really fire prone, or can it prevent the fire occurrence? What is the probability? And what about the durability of the structure with respect to the weather's changes that Chandrapur is being subjected? Sometimes during the winter it goes up to 8 degrees. In the summer it goes to 48 degrees. Whether it can sustain these kind of temperature changes, that is another challenge we have it. And the third challenge is, apart from this fire and durability, can we use the local materials? In this material, this is another disadvantage what I have seen is we have procured material from elsewhere, some from Assam, some from Sindhudurg and all. With that, the cost effectiveness has gone up. The cost has multiplied like anything. So if we come to a stage that where we use the local material, probably this cost can be curtailed even to 20-30%. The cost of the structure, which I was mentioning, is 91 crores. Because some of my engineering friends have come and visited, they also had the same impression. Yes, there is nothing wrong. The structure is good. It's innovative, new, very good looking, and one should think of such structures. But the problem with the structure is it is not cost effective. The cost is much more than the traditional buildings. So the reason being, we are using material from elsewhere. If we develop a mechanism or develop some kind of practices or some kind of theories, so that the local bamboo, the local available bamboo, because Chandrapur, Gondia, Nagpur, Gadchiroli, like these issues, they have abundance of bamboo. If we use this local bamboo, probably the cost can come down. That was my third challenge that we should think of. Then if suppose if all these challenges are made out, then if we found that this can be, yes, this can be a construction material, then and it can be a substitute for it, then probably this will be the biggest revolution, not for the big projects, at least for the rural needy people, because the rural people, the tribal people, the poor people need some low cost housing structures where they need a low cost building material which can be renewable, regenerable, and which can be available at very low cost. So I think with that we should look at the, can bamboo be a substitute for the RCC or the other metal structure? If we come to that level, I think probably our journey will have some sense and will have a satisfactory end. And present, this is our BRTC, the structure for what we are spending some 90 crores rupees, has some research going on for bamboo pyrolysis with the help of NEERI, and some certificate courses are also being run by our BRTC director, Mr. Rahul Patil. He is a very dynamic officer. He is taking care of all kinds of innovations. Right now, we have some certificate courses are there, some 70 days certificate courses for basket making, handicrafts making, furniture making, and some construction materials making. And we have a 2 years diploma in bamboo technology course also, with the affiliation to Maharashtra State Board of Technical Education. It's a 2 year course, and these trainees will have exposure to different IITs, NID, IPRT, and Woods Institute of Technology, Bangalore. And right now, the BRTC is having some 19 common facility centers at different places in Maharashtra. In Chandrapur alone, we have some six common facility center. There, these trained people will be brought to this training center. They will be given the raw material. They will be given the opportunity to make the articles based on the trainings they have. And we have provided them the forward linkages of marketing facilities also. And we have a bamboo toothpick unit, which we are having a marketing facility at Mumbai.
I think we lost him. I think we are having some issue related to connectivity. We just wait for it to come back.
Structures for the rural needy people. With this, I conclude my initial remarks and look forward for other speakers, and would like to participate in the question and answer sessions also. Thank you very much.
Thank you, sir. Thank you, Ramarao, sir. It was indeed very enlightening to listen to you and also to understand the challenges that you were facing. I think I'm sure it must have helped a lot of people understand your point of view. We now have Shri Ulas Debadwar, sir, our chief engineer, dynamic chief engineer of PWD, as I call him, who is looking forward to a visionary change. I would also request him to let us know the challenges he faced as chief engineer PWD. Though he is always positive and always forward looking, I'm sure he must have handled the situation very well. And we are eager to learn from you, sir, how you handle the situation. Welcome, Devadwar, sir. Please join us. So I think you need to open mute. Yes, sir. Yeah, now you're good.
Thank you, Mishra sir. Looking to you after a long gap is a very pleasure for me.
Yes, sir. Thank you.
And
Thank you. Same here, sir.
thanks for giving me the opportunity to share the views about for the government as well as for the architects and engineers. तो मिश्रा सर आपके बहुत मैं धन्यवाद करता हूं, और उसी के साथ मैं रामाराव सर के भी धन्यवाद अदा करता हूं. बिकॉज ऑफ हिज प्रेजेंस ओनली this project could see the light of the day, in fact. And it's a good example if a teamwork happens, then how the outcome can be, because such projects need innovative things, moving out of the track, going away from the traditional methods and taking the decisions. So all those things have happened in this project particularly. Just I will share within 2 minutes what has happened. Shift is an institute who is working in this field since many years. So Forest Department, with the help of Tata Trust, they prepared this project and they decided to bring this institute, Bamboo Institute, in the bamboo construction only, so that we can keep that example in front of the people that the bamboos can be used for the structural works as a structural element, and it is no more a only decorative material. And to show this on field was very important, to make use of the bamboo as a structural item to be used in the columns, in the arches, in the beams, in the long spans, and to sustain that. So all these things you will find in the institute's work, and I think that has given a very good confidence amongst engineers also. In addition to the architects, now engineers are also confident that they can feel that yes, this material can be used for the structural work. That is the biggest benefit of this bamboo institute that is coming up in the Chandrapur. And definitely why I praise the role of Ramarao sir is the rightly जैसे मिश्रा सर आपने बताया कि फ्रॉम गवर्नमेंट पॉइंट ऑफ व्यू वहाँ के क्या क्या हर्डल्स आते हैं और कैसे कैसे दूर किए in a very short span of time. It's difficult to tell, but getting the administrative approval from the user department, communicating with the user department about the intricacies of the project, variations in the cost implications, changes of the decisions, इसमें रामाराव सर का बहुत अच्छा रोल था. Therefore I praised him, just not because he's present, just but because of his contribution in getting the financial sanctions at appropriate time and keeping the project on the fast track. And because of that the things could happen. And secondly, I think in this workshop you have kept the talk of Mr. Krunal, who is very important person, who is a contractor for this work. He can share the experience of how the bamboo search was made, how the components were prepared, they're assembled, brought at the site, the treatments given, the time span required, the labor management. So these are some of very important elements. Those may be highlighted in his speech. Now the coordinated efforts of all these officers and contractors and the people have given the outcome of this pump. Now most of us are architects who are listening to this workshop. That is what I understand. I don't know exactly what the participants are, but from the architectural point of view, what I would appeal is just have a look at the institute. It will boost your confidence, and then you can think whatever designs you are preparing, some of the components, if you convert those into the bamboo structures and going beyond the interior, converting that into few of the structural elements. I don't say that after seeing that immediately you will go and construct a big building. It may not happen quickly, but in couple of years, what I am seeing is in another 2 years of time, the codes will be prepared and those will be available for the public at large to make use of bamboo for the structural elements. That is what I'm dreaming. That is first thing. Secondly, in addition to interior, if we use the bamboo in different elements, it will add to the elegance of the building. Secondly, being a green material and environmental friendly, we will be able to promote this material. Thirdly, as compared to all other materialistic elements, bamboo is going to the close to the nature rather than going for the concrete, steel. If we replace those elements by bamboos, naturally you are going closer to the nature. In addition to that, then it will create the labor potential and it will add to the industry, and all those things are definitely will happen. What I would request the participants is whatever projects they are preparing, a small component of the project, maybe 10%, 15% out of 5 buildings, one building, out of some 10, 15 elements, 2 or 3 elements of bamboo. If you will propose those, it will give boost to this I can say this innovation. And when you are proposing that, you have to convince the client that it will be useful, and that confidence will be generated after you will visit our site. That was not available for us 2 years back. We were just moving in air, just keeping hands with each other, forest department, pwd, shift, Tata Trust, and it is only the confidence in each other that they will give justice to the role that they are playing. With that confidence we entered into this venture, and now it has come true. Now again it will need some 5 to 10 years of time, whether our decisions were correct, whatever we did there, whether those structures are performing the way we thought and we designed for it. But I feel, except the fire registers where we are looking for some alternatives, as pointed out by Ramarao sir, rest of the things are, I'm confident that those will prove and will be available over the period of time to see everybody, and they will find that these elements are functioning the way they are designed. Only one thing that I am coming there, again, being a Chandrapur city where there is large temperature variations, there is huge pollution because of the industries around that, and there is every possibility that our bamboo structures will catch the dust. And how those will look, we are taking care of that also, fire protection along with this thing, how we can do it, how far it will be sustainable. जैसे हम अपने बिल्डिंग को पेंटिंग करते हैं, तो वो पेंटिंग की फ्रीक्वेंसी बाम्बू में हमें बढ़ा सकते हैं क्या, एंड हाउ दैट कैन बी ड्यूरेबल. So these are some of the areas where we want to work, and I'm sure we'll come out of those things also, and a good structure will be available for others to follow. Rest of the things, sharing of the experiences, जो भी कोर्स अवेलेबल है जिसका हमने यूज किया, those we can share with you. Those are available with the shift, those are available with the PWD and Ramarao sir. We can share those things with you, and on the basis of that you can create something new and something additional wherever we have gone. I appeal the participants to think in these lines and to take a leap forward in the direction of this bamboo. Actually it will add to our economy. Bamboo being a local material का यूज हम जैसे जैसे बढ़ाएंगे वैसे वैसे उसकी कॉस्ट भी कम होती जाएंगी, plus we will be able to promote the artisans in the local areas. And those things have been started in Chandrapur and Gadchiroli, not as a very fast pace, but after the construction of this institute, people will visit that and they will appreciate it. And this is what I appeal to all, to visit the location, and whatever the questions, as far as the government is concerned, there are different approvals, technical sanctions, tendering process, then approval to the tenders, then a few new items coming in the form of extra items, additional of the quantities, changing of the decision of the site. These are some of the elements that we need to consider, and I can say all these things are rightly addressed by many of our officers, like Superintendent Engineer Mr. Balpande was there, Sakarwade Madam was there, Mr. Jaiswal was there, and Mr. Bhaskar. These four officers are well acquainted with the intricacies of this project, who can be helpful to the participants if they want to add something to their project by inspiring from this. I appeal everybody to go ahead with this. As far as I am concerned, in my government works, I am going to promote the use of bamboo structures in future works. So with these few words, I thank again JJ School of Architecture and Mishra sir for giving me the opportunity to share my views. Thank you all.
Thank you, Devadwar sir. It is always a great pleasure to listen to you, and it is
Sir.
wonderful to know all kinds of good words you said about bamboo construction. We are also, like you, thinking about promoting bamboo. And as a school of architecture, we want all young architects and architects to look at it very seriously and make it a eco-friendly building material. Now that a background has been created by Ramarao sir, Debadwar sir, and Gande sir, it is now going to become very interesting to see how architects have designed this structure. So I invite Mayank Mishra from Shift, which is nothing but a sustainable studio for habitat futures, where he will try to present all that has to be explained now with the background already explained by our earlier three experts. So now we will look into phase two, where the architect will present his design. It will be followed by the structural engineer who worked with the designer, which will then be followed by the project management consultant who actually implemented the project. After which, it will become easier for us, me and Sanjeev Karpe, to conclude the session and take your question and answers. So, Mayank Mishra, our alumni from JJ College of Architecture, I invite you. I hope a lot of transformation must have happened to you after you graduated and now. So, please let us know all that you could manage to learn after graduating in a small way, because it will help our students understand. And then you can begin the project in the interest of promoting bamboo as a building material. Welcome, Mayank Mishra. Mute.
Thank you, sir. Good afternoon, everyone. It's a pleasure coming back to JJ, whatever means it is. I would really like to thank everyone, our other eminent panelists also, who were part of our team, who really helped us a lot while we were conceiving this project and while we were thinking to execute it. It was the support of each and every department which made it possible. As correctly informed by lots of other earlier panelists also, it was really important for all of us to collaborate together and work to create something which is unique and can be done in something like bamboo. So I'm going to start the presentation. Is my screen visible? I presume yes. I think so. Yeah, screen is visible. Yeah. So I'm going to talk about Bamboo Research and Training Center, the learnings about this project. And before going to that, I will also talk about bamboo, of what bamboo is all about and how it can be used. What bamboo is? Most of us know bamboo is a rapidly renewable grass. It gets grows in 3 to 4 years to be used for construction technology. It also does mean that we need to take care of the species of bamboo that we are growing and the way we are growing this. I think Mr. Karpe from Konbac will explain what kind of species are required for what kind of applications, and that really makes a huge difference in the way the application is done for that material. But of course, it's a rapidly renewable grass. It grows in 3 to 4 years, ready to be used. It reduces soil erosion dramatically. It sequesters carbon dioxide, which means that this is the only material that instead of producing carbon dioxide, it actually sequesters it, which means that if you're using bamboo, it will reduce your carbon footprint rather than add it to the environment. All of us know that bamboo is there as an element, as a member, which has been used in various handicrafts and other things. But can bamboo be used as a structural element? Traditionally, yes, bamboo was used as a construction material. Most of our rural houses used to be get made in bamboo, but it doesn't inspire most of the architects to use it as a modern material. What happens is it has been considered as poor man's timber, but certainly now in today's world, it has taken over wood and can be considered as a substitute for wood altogether. Bamboo can be used as a whole, as an element. It can be used as engineered wood. There are various forms of bamboo which can be used. It can be used as board. It can be used in interiors. It can be used in structural members for cladding and various other ways. So yes, bamboo can be used in construction technology in today's world. Can bamboo be used in a modern architectural practice? Can it be shaped like steel? We are very much well aware about steel structures, the way they have been shaped today. All of us love it. As an architect, it really excites us a lot. But what we need to understand that all of these structures are resource efficient structures, which means that the steel, when designed, has been taken care, the care has been taken that steel has been designed in the way the steel is supposed to behave. Similarly, the concrete is designed in a way where concrete is supposed to be behave. So can bamboo do the same thing? Structurally, yes, because if you see the tensile strength of bamboo, when you compare it per unit weight of bamboo to steel, it is higher in tensile strength as compared to steel. The bamboo has a higher tensile strength. It does have various other issues related to its other compressive strengths and other things, but that can be taken care of if we are able to design the structure in that way, which really opens up a new ambit of practice for structural consultants also, which means that we need to design buildings in a different way. We need to get new codes in place. We need to have new methods to design these structures. And yes, it can take various shapes. We, depending on the dia of bamboo that we use, we can you allow various kind of shapes with the same material. Can we rely on bamboo like other industrial materials? Most of our industrial materials have their advantages and disadvantages. We have gone through it. We have prepared various kind of solutions for it. Like for steel, we have various kinds of coatings that can take care for it. So we know pros and cons of that material. Similarly, for bamboo, we do know that there are borers and termites that can create an issue for bamboo. The weathering can be one of the issues, but all of these can be taken care by having various kinds of treatments, having design which can make sure that it is not directly exposed to those kind of weather conditions, and all of these things can be taken care of. So yes, bamboo can be used as a material in today's world. What are the global examples that we have? Famous architect Wong Trong Nha from Vietnam uses bamboo very often, and the structures really look very great. You see the dia of bamboo and the kind of design that you see over here. Similarly, Simon Villiers, who's also one of the inspiring architects look look at his work for, also uses bamboo. And now the difference that you see in both of these structures is actually the difference of the dia of bamboo, which defines the way the structure has been designed. Some more examples of architects of Mr. Simon Villiers. So if all of this is possible, then why are we not using it in India? The first question that comes up is, do we have skills? Do we have capacity to build something in bamboo? The rightmost picture on the top right handmost corner that you see is of a hut being made in bamboo, completely in bamboo. This is a rural house in Arunachal Pradesh. It is on a cliff at the edge of a hill, almost hanging like falling waters, I can say, with a natural material. On the right hand side, you see a house getting being made in bamboo. So yes, certainly we have skills to build in bamboo. Now, it's not only skills that we have to build in bamboo, we also have craftsmanship that can be used with the material like bamboo. So culturally, we had these skills. We were able to use these materials as building material and also as crafts. Can bamboo buildings be structurally certified? This is one of the examples. This was done by a joint effort with Shift, Sanjay Prakash and Associates, earlier known, Pradeep Sachdeva Architects, Environmental Design Solution and Integrated Design. This was world's largest bamboo dome at that point of time. This was Shanghai. This was in Shanghai, Indian Pavilion, built in 2010. This building was certified in India first and then taken to China and then was checked and certified by Chinese engineers in their codes to be made in China. So this is possible to do. It is possible to use structures, structural elements that can be certified by structural consultants. Of course, there are lots of work that has to be done in codes, but certainly in today's world, we can start working with structural engineers who can certify these buildings for certain kind of things. Uh, this is a picture at the day of inauguration. You can see lots of people lined up wanting to enter to this project. So I think we got the maximum footfall on day one to see the bamboo dome. Now coming to the story of BRTC. So having the experience of all of these, having global exposure, there was an initiative of government of Maharashtra and Tata Trust, and something about which our earlier panelists have already spoken. The main concern was to create a project in Chichpalli, very close to Chandrapur, uh, and as correctly said by Mr. Ramarao sir, that it has lots of bamboo going over there. It also has a Tadoba National Park, which has lots of tigers in those areas. One of the stakeholders of this project are the tribals of this area, whose main livelihood depends on forest and the buffer zone of forest, where they actually collect biomass and sell it outside, which does make it a conflict with the wildlife. If they are entering into the wildlife areas to collect these biomass, of course that would create a conflict for the wildlife and for the humans. On the other hand, this is not a fixed source of income, which is not a reliable livelihood opportunity. And as tribals who always had entrepreneurial skills, this is not something that we would want them to do. Uh, India has a huge population which is aged between 25 to 50, which is wanting to have various kinds of skills to earn their livelihoods, to have employment in various sectors. And of course, there is possibility of bamboo to be introduced in this area where the skills can be developed. There are lots of farmers who are in distress today because of the crops, because of the rains. Sometimes they have no rain, sometimes they have too much rain. All of these creates an issue for a farmer. So growing bamboo can also help them because it's a sturdy crop. It can actually withstand these weather conditions, would assist farmers to have additional source of income. So a bamboo can be linked to them also. Having the products being made by these elements can actually be also be sold in market very easily. So all of these can be linked through bamboo, and all of this when sold in an urban scenario, the money generated from these sources goes directly in the hands of these people who are in need of this kind of livelihood, then ends up promoting bamboo, which is a sustainable material, ends up promoting farming for bamboo, which is also one of the better ways of having farm lands, and also reduces the wildlife conflict on the other hand. So the design brief that we had was to create a state of the art center which would promote various technologies, where people would be able to do research and make various kinds of furnitures, work in construction industry, handicrafts. This would help them to create local jobs, make lots of micro entrepreneurs, and promote building industries. So these were various courses which would be done in this institute, various kind of courses. Of course, it would also mean courses for awareness and skill India, which means the engineers and architects need to come to this institute, work with these artisans, and make various kind of design, be it furniture, be it building industry, all of these. And this institute will provide a platform for architects, engineers, artisans, and all of them to work together to create something in bamboo. We'll quickly jump to the site plan. The site is here. You see the highway on one side. One of the first thing that we did was to create a first building, which is this building, as an exhibition block, which would be the first building for which can be considered as a test project. And after that, the complete project was taken up. So the designing and everything was done of the complete project, but the execution was started from the test building, which is this building. This is the exhibition area. This is the administration block. Lots of people would visit this area, see the products being made over here would get exhibited in this zone, in the exhibition area. The central block is an academic and the workshop area. Behind that is the residential area, and after that is are the hostel blocks, and then comes your STP and other parts. So I will quickly jump. I will go through this slides. This is the academic building block. This block is the only block which has first floor on it. Other than that, other blocks were ground and ground plus half kind of a structure. Uh, these are some more views and sections. I will not go through it. The idea, now this section will explain. The idea was to, after ground level, we should use bamboo as the structural element. So bamboo was used in every form, be it columns, be it beams, be it purlins, bamboo mat, and all of these things. For infill, we felt that instead of using bamboo, we could go with another material which is rammed earth, which also helps in reducing the temperature difference from outside to inside, and also gives a very good look to the whole project in a way. So the other material that could be added to this was rammed earth walls. A business as usual approach. What would have happened if you would have gone by business as usual approach? That would mean that architects and engineers would design something that would go for mock-up, where the technologists and craftsmen, I'm referring to construction managers, PMCs, all the bamboo and rammed experts, and craftsmen as the agencies who are executing it, would make a mock-up, and then they would give their inputs. It would get redesigned. Architects would define what needs to be done. They would take the front seat and everyone else go on the back seat, and then everything gets executed. But here it would have not been successful if we would have not gone by collaborative approach, which would mean that design then collaborate with all of them. The designs which were made were sent to all of these people. It was discussed well in advance before releasing those drawings for mock-up. Then the mock-ups were created. Again, after the mockups, there was a collaborative effort to see what is it, how the members are behaving, how the elements are behaving. We would go back to design board, redesign it. Again, the whole process was finished and sent to the technologists, craftsmen, and everyone else in the team. And after that, only it would go for execution. This does mean that there was initial time which was taken up for collaborative effort, but at the end of the whole process, it really saved a lot of time for all of us because we didn't have to re-innovate everything. So a collaborative approach really helped us a lot, and in all of these approaches we got a huge support from government of Maharashtra, all their departments and the clients particularly, who always supported us and allowed us to do various kind of changes which was not easily acceptable in business as usual approach. We would end up saying, ha, ye beam mein there is a problem, we need to change it, and that would be just after the mock-up, and we would change it, redesign it, and reissue the drawings and redo it. So this was something which was required for a project of this type. These are some of the pictures of various mock-ups which were done before the drawings were even made. These are some of the pictures before the drawings were sent before the execution. The rightmost picture that you see are of the engineers, building technologists, our electrical engineers also standing there. I don't know why. I think he would also have some suggestions to give. And lots of people on site who would execute it, who would sequence the construction process of how rammed would be taken up, how bamboo columns would be filled in. We got a huge support from Do Studio Auroville, who helped us to create these rammed walls and helped us to do the transfer of technology over there. So now we have people in Chandrapur who can build rammed walls. There were another various things that were done. The configurations of the buildings were done in such a way that the first project, which was the experimental block, we used bamboo as a whole. All the elements were assembled on site and then executed on site. This was the first one where the bamboo which was used was of 100 dia, and you see the difference in the way the spans are being taken care of. The other approach that we took was to mechanize and prefabricate most of these elements. So all of these elements that you see over here were prefabricated in a factory and then brought to the site and assembled. So the columns were assembled, the trusses that you see on the top were assembled. All of these were prefabricated. It reduced the time consumption on site. It helped us to manage the quality and also gave the confidence on site for people who were getting it executed. Oh, something is happening. Other things that we did was that all the columns and beams were also prefabricated. The elements were made beforehand and were prefabricated and then assembled on site. Bamboos were used in various forms. As you see over there, there is a bamboo mat. You see bamboo floorboard. This picture, I will explain you what does it mean, why all of these are standing together. This is pre-COVID times. The bamboo was also used as a roof covering in shingles and other parts. What are the areas of research now when it comes to bamboo? Fire retardance does remain a concern. We had designed these buildings so that people can evacuate the structures in 45 minutes. There are few areas where RCC staircases were added so that evacuation becomes easy, and also takes care of the national building code. There are various coatings which are available, which is being used in wood structures that can be applied in bamboo, and this is a area which we are working on, and I think we are being able to be successfully demonstrated, which would increase the fire retardance of this element to 2 hours. Naturally, bamboo does have a fire retardant properties because of its outer shell. So the outer shell does retard a lot of fire. After that, if the fire goes inside, that is where the collapse starts happening. You need codifications for the control of cracks, which means because bamboo is a linear fiber material, it grows naturally in a linear way. You need some codifications for cracks to be controlled. There is a brittleness in this element, which means that there would be some deflection after the building has been designed, so you need to take care of that deflection, design for all of these things. There is a variability in material. There are various dias, and all of this is not easily taken as a easy thing for structural consultants. They would say, okay, please define 50 or 75, while you would end up getting 60 or 85 kind of dia. And plus the dia would also vary at the start of the material and the end of the material. So these elements, the variability of natural material needs to be taken care of. There are joints. There is a huge research area in joints that can be taken up, which can be uh, the next area where the codes and all of these things can start defining it. This photograph that you see over here is actually a load testing for deflection at a lower level, where our structural consultants and our proof consultant is standing and checking what is the kind of deflection you're getting with this bamboo beam. And you see all of them collaborating together. So you have our site person from KONBAC who's standing there trying to see what is happening. You have structural consultant, you have people from PWD checking what is happening, you have Dr. Abhay Gupta checking if the beam is behaving in the same manner or not. So it's a collaborative effort, and that is something which would be very much important. These are some more tests which were done before hanging these beams and checking the deflections. There were some additions to these structural elements on site before they were added to the whole member. Of course, we also did lots of tests by our own on in the factory itself to check various kinds of deflections that can be seen. I will quickly jump to the site pictures now. These are some of the pictures. This building that you see was done in 100 dia bamboo. After that, we recognized that we should promote the bamboo of Maharashtra, and after that, we have used all the bamboo being grown in Maharashtra. Particularly, we couldn't use bamboo grown in Chandrapur because it was not of that category that could be used for structural element right away. There are lots of variation in nodes differences and all of those things, but we feel in future that could be easily taken care of if we start promoting the growth of bamboo in a particular way. After this building, all the buildings were made in 50 dia bamboo being sourced from Maharashtra itself. This was the first building in 100 dia bamboo. There you see various kind of shapes and form being taken. All of these elements are structural elements, and all of these were done with structural consultants and various other participants like our site people and all of them, including KONBAC, including inputs from PWD department or forest departments. So more pictures, some more. This is before construction, this is post construction. So this picture on your right hand side, you see the structure has completely changed. The way the structure has been designed has been changed because the dia of bamboo has changed. We need to make sure the dia and the kind and the species of bamboo that we are using, we are designing for that species. Some more pictures. These are large spans, about 15 meters in one direction. Some more pictures. Yeah. In this project, we have used approximately 43,000 running meters of bamboo, which would have benefited about 54 acres of bamboo farming, which does mean that there is a positive footprint that this project has given. It does mean that there's a lot of carbon being sequestered by using bamboo instead of using concrete. It has generated about 420,000 man days in bamboo construction itself. It means that you are giving jobs to green technologies, and that is a way forward for all of us to look at. Thank you.
Thank you, Mayank. I think that was a wonderful presentation. Totally mind
Thank you, sir.
blowing. It was so engaging, and every detail after detail that you were presenting. I think with your explanation, we understood how the form using bamboo is affected, the
Right.
shape of the structure is affected, and therefore now I think it would be very interesting to listen to our engineer, Sri Gupta, who actually was working with you that helped you decide the final form that the structure took because of the bamboo, the large spans that you could modify based on the behavior of bamboo as a structural material would basically be now understood by our structural engineer who was involved in this project. Dr. Gupta, as you know, is from Roorkee and also an academician for 23 years. And therefore, I'm sure he will put it the right way. But many of the questions that we had to answer was how will you take care of the tear factor in bamboo? How would you take care of the structural strength of bamboo when the weather changes? And how bamboo will then be a safe material to behave with? So I invite Dr. Abhay Gupta, please, you can reinforce the presentation of Studio for Habitat Futures presented by Mayank. by your small talk of structural analysis of the design presented by him. Welcome, Dr. Gupta.
Thank you. Thank you very much, Rajiv ji. Good afternoon, listeners, curious participants to this very different kind of the construction technology presentation. And we are happy that we have successfully constructed these three huge structures which are purely in bamboo and rammed earth. We are not using any concrete or steel here. The design. How can I share my screen? Hello.
Hello.
I can use the share screen option from here.
Yes, sir. I think you should be able to do that. I think we can ask the IT support to help you. I'll just call him. Yeah.
Abhayji,
I think he's coming.
you will see the share screen.
Okay, so is it
So first
my
you
screen is
open
visible?
your presentation. First you open your presentation. Yes.
Yeah, I have. Yeah,
Now
this is
you
visible.
can go full screen. Yeah, this is visible. Now you can go full
This is
screen.
visible.
Sure. Thank you. So the pride project of Bamboo Research and Training Center, which we have done along with under the guidance of Studio and the officers of PWD and Ramarao sir, and very well guided by our very experienced team of Giants Bamboo. Gandhi is there, Nalne Gandhi is there, Mr. Sanjeev Karpe is there. Skeleton Consultants Private Limited, who are working hand in hand with Studio Shift, have done the entire designing, and we are proud to put this project on our main display screen of our organization also. That is what I wanted to show. I don't have a formal presentation kind of the thing to be shown, but I will take the audience through the structural engineering process for such an unconventional structure. Primarily, whenever we start the structural engineering for a project, we look for the material and the material properties. As far as the concrete and steel are concerned, we are very well aware about their characteristics, properties. They are well documented in the codes. Here also, we are helped by one code, IS 15912, which is in practice, which is in use by from BIS, and this is structural design using bamboo. For those who want to learn more on the structural design using bamboo, this code is a very good document for the reference. This particular code, it provides all the information about the bamboo characteristics, various types of the bamboos available. This table gives the various varieties of the bamboos which are available, and recommended properties are there. So we have taken this code as our guideline for the bamboo. The main challenge was what is available in the country, which variety and which is going to be used. So initial inputs from Studio Shift were that we are going to use 100 dia bamboo of this particular variety, Balkova. We looked for the variety, the properties of that bamboo, and when we say bamboo, certainly in mind the thing comes, it is a round hollow pipe. It's a round hollow tube. Even the code IS 1592 very clearly mentions that we have to consider them to be hollow steel tubes only. So that was one guideline for us. Then the next challenge was how many of such to be combined together to form a particular component. So the main contribution that our team did was to devise to use various configurations as suggested by Studio Shift in columns, in beams, in various flaring elements, that we need how many bamboos there to give a particular shape and size. So with each of them combination, we worked out the geometric properties of each combination. Suppose in a particular element, we need some 20 bamboos of 100 dia. Then how are those 20 placed? they are arranged in a rectangle or some plus shape or what. So for each of these shapes, we prepared a table of their modulus of their moment of inertia, section modulus, and their effective area. And then we modeled the entire structure in a standard software. We all know, all the structural engineers know STAD software. In STAD, we considered the elements to be steel tubes, but rather than the properties of steel, the user defined properties we have used. So there we gave the input of the bamboo properties from this code, where it is clearly indicated that the permissible stresses to be used are like this with the factor of safety. This is one very important aspect for designing the structures with bamboo, that if you see the factor of safety are like 4, 4.5, 3.5, means a very high value of factor of safety is recommended. Now there are reasons for that. Why such a high factor of safety? Mayank has already explained that we need to understand the bamboo which is grown. It is a natural material. Bamboo is not a factory made product, but even then we are using the prefabricated or pre-assembled technology. But the variation in the properties, the characteristics of the bamboo, like the diameter varies. When I say 100 bamboo, it is not 100 throughout. It may be 100 at one end, it may be 80 at the other end. If I take the longer one, the first photograph which Mayank showed, the growth of the bamboos, then you could observe that they are very thick at the base. While going to the top, they were thinning. Means we cannot use a very longer length of each bamboo. So the restricted length was about 4.5 meter, which could be used. Means there will be several joints in the bamboo by itself. So that was one of the challenge. Another was the wall thickness. Now wall thickness, in general, we were told that 10 thickness is there. But that 10 also is not a constant thing. It was varying. So when we did the first design, we considered everything to be 100 and 10 and we produced a design. Means number of bamboos required in columns, various elements, beams and all that. And then we, through the mock-up test, we loaded the structure as a mock-up and we observed that how much deflection the beam element is having actually, and we compared that with our STAD analysis. We observed that there are deviations. Whatever we are seeing in the STAD model is not exactly we are getting on the side, we are getting larger. Now, what is the reason? The reason is very simple. I am assuming that there are 10, 20, 40 bamboos combined together, and those bamboos are behaving like one single element. But no, it is not like this. The bamboos need to be connected together, and that is where the experience is required. And that is where two people helped us a lot. One, Mr. Himanshu Tulpuleji. He is an experienced structural engineer working with bamboo since long. And another one, KONBAC and Mr. Kunal Negandhi, his team itself, Mr. Uday, their engineer. They helped us a lot in working on efficient jointing. I would also like to put forward here or inform all the people that the entire structural design has been proof checked by Professor Prem Krishna. Professor Prem Krishna is a former professor of IIT Roorkee, an expert on wind engineering and steel structures, and he guided us on achieving the targets on the serviceability. So as a structural engineer, which the strength and serviceability, these 2 points which were very, very important. The strength we achieved by combining several bamboos, but on the serviceability side, the deflection was giving us a challenge. The actual deflection in the structure, I have no hesitation in accepting, because this was the first project of this nature, where we have used long beams, big arches. We have used 11 meter span truss, which is really a big size. So all these were first time we are using. So the deflections of the members after the complete erection even were significant. They were visible. We are habitual of seeing the RCC and steel structures where the deflections are in millimeters, and as compared to their span and sizes, we are not able to visualize them. But here we were able to visualize, and site team was very efficient in giving us a regular feedback. So based on their feedback, we were altering the design of the elements. We were adding some bracings. We were converting the nature of the member. So with all that, we were able to produce an excellent combination of these three big structures. One of them is a workshop building, one is admin building, one is the academic block, which is a 360-degree complete round structure. But there are two more structures on the background in the site plan which Mayank has shown. There are two hostels. Those two hostels are RCC buildings, but the top cover, the roof on the top, we have used the bamboo arches to cover them. That looks beautiful, fantastic. So here I would like to inform all the young engineers, architects, and other who are listening to me that it is a completely prefabricated kind of construction where all the elements you can fabricate in a factory, because there is treatment required, because there is jointing required. So you can make them in a factory, bring to this site and assemble them very efficiently. This is a very good concept which steel structures are using, but we can very well import that, or we can transport that to the bamboo structure. One photograph which Mayank has showed where 30 people are standing on the floor. There was a query raised from the PWD department that whatever you have designed is very good on the software and in the theoretical, but we would like to actually see, because when the people walk, when the people walk on the floor, there are some vibrations or something. So we want to be sure whether when the load will come, how it will be here. So we made an actual live load test of the prototype, and those 30 people together weighed 2000 kilograms. That 2000 kilograms divided by 300 kg per meter square over an area of 6 meters square, we made them to stand in stages and recorded the deflection and then unloaded and again recorded the recovery. And to the happiness of each one of us, the recovery was excellent. Almost 99% recovery of the elastic deflection was there. So that gave us a confidence to us also and to the PWD department also that this structure has been well designed and constructed, and the joints are also working properly. Now here on the joint side, though this code also provides some guidelines on the joints, those who are interested, they can further read this. There are some very good illustrations, but you can see that there are some strips which are used. From architect studio shift, we had one restriction, we had a limitation initially that we should not use any strapping over the bamboo bunches because that doesn't look good in their aesthetic sense. So we used all the connections with the fish plates, MS plates inserted between the bamboo, and then use bolting. So all the connections are bolted connections, means you even can't see them from a little distance that there are bolts and connections are there. So the beautiful structure has come up. One architect who visited the site once, because there are many people who come and see and it is being published. So one architect, he came and he was so happy, Rajivji, that his first comment was, it's a musical feast to walk in the corridor of this bamboo structure. It really looks very elegant. Friends, this is about this particular project, but those of you who are interested, there is a lot of very good material besides this IS code which is available. And as Ramarao sir and Chief Engineer sir has said, that whatever information we have, if any of you is interested in working with the bamboo structure, then a lot of information and support we can share. So some of the pictures have already been shown by Mayank. As of now, from my side, this much I would like to convey as far as the structural engineering is concerned. When we will enter into the question answer session, I'll be responding to your structural queries. Thank you, Rajivji.
Yeah, thank you, sir. Thank you very much. I think quite clear about the elasticity modulus and the ratio with which the bamboo bends with respect to the tension. It was quite interesting to know that all loading tests and everything that you were able to carry out. And this prefabricated
Thank
material
you.
or putting it to this was quite interesting. I would now request the gentleman who was responsible for implementing the design. You know, I think Negandhi sir should now help us understand how, after architects and structural engineers have given them drawings, they have managed to execute the project on site in a given time, in a given cost, and how successful they were in getting all prefabricated units assembled on site for the faster completion of the building. I welcome you, Krunal Negandhi, for your presentation. Thank you.
Thank you, Mishra sir. This is a great opportunity and honor to share the webinar with eminent people, and I thank you for this opportunity. This project wouldn't have been possible but for the positive mindset that was shown right from PWD to the forest department, the architects, and everyone together. Because when you try and do something unique and something, attempt it for the first time, the only thing that you know is the unknown. So you're going to keep on stumbling across things. So that was what was known, and had it not been for these people, it wouldn't have been possible. So I'll just share a little about us. Our journey started, like my personal journey in bamboo started when I was with Lavasa. About 12 years back, 13 years back, I decided to make a net zero nature trail. And this is a picture of Lavasa. And we wanted to build this trail using soil and bamboo because we wanted it to be completely zero carbon. So we worked with, at that point of time, KONBAC as an NGO. We had the best resources in the world. So we identified them, we worked together with them, and we built few structures, landscape elements like gazebos, machans, etc. And the more I as a civil engineer, got in touch with the material, the more I used to feel why we don't see this, everywhere. I mean, this is fantastic material. The aura of the material is fantastic. The tensile strength is good. You can build multiple things. Why we are not seeing it? And my background being sustainability, I have been the head of chief sustainability officer for a very long time, and I've been part of IGBC, LEED, and Griha, all of them, and I used to look at green buildings, green clusters, and what I realized is that although we talk about operational energy reduction, when we talk of buildings going green, the biggest issue, if you see, is the embodied carbon itself. So the Architecture Digest 230 has indicated that by year 2030, the 74% of the entire issue of carbon sequestration or GHG gas emissions coming from the construction sector is going to be 74%. And what options do we have for embodied carbon? Hardly do we go beyond concrete and steel, as a material. So it was very intriguing to my mind that why we are not doing anything, as engineers. Why, when we do something, it always has to be a negative impact, and why can't we look at negating that impact? So with that in mind and understanding, we started off understanding more about bamboo. Mr. Mayank has already shared few characteristics. I'll just touch upon it a little more. The most interesting thing about bamboo is that if you don't treat it, it will anyway start to decompose from 6th year onwards. So although it is one of the fastest renewable material, there's no fun in not cutting it. If you cut and treat it, it will last for 100 years. So what you effectively have is a God-given natural material which can store carbon dioxide in its body for the next 100 years, and recycle that into the atmosphere. That to me was the point when I decided to move out from conventional work and completely dedicate my time, energy into building bamboo as a mainstream construction material. So as a corporate person, I have been 21 years working with large multinationals and have a habit of benchmarking. So I started looking at what is happening in the country. So even when we talk of bamboo fencing in the country, this is the kind of pictures that come to your mind, vis-a-vis what you see in other countries. Simple structures like fencing or furniture, or bridges, These are the bridges done internationally. You see this bridge, these are called bamboo gazebos in the country. Vis-a-vis gazebos done outside. So as I started knowing more about it, the more I realized that somewhere there's some big problem in the country. Although we have so-called second largest biomass of bamboo in the world, we are just not been able to do beautiful structures. We are just not been able to do structures which generate that wow, which we see otherwise. See this structure in Vietnam, for example. Mayank also shared many of these images. So with that in mind, I have been part of TERI for a very long time, and right opposite TERI University is Madhyanchal Bhavan. And this is a structure which was done as a demo structure, which turned out to be something like this. So if you see internationally, the world of bamboo construction has gone far ahead, with architects like Simon Wellies and Strong and other people who have worked. It's fantastic. So these images basically indicate what is possible, and then how come it's not happening in the country. So what I realized, initially was the problem is that one doesn't handle the entire ecosystem. So unlike when you want to do a concrete structure, for example, you don't go and mine to make cement. You get cement from the factory. You don't go and mine steel ore to make steel rods. You get steel rods in the market. And what you do is you just construct. But that doesn't happen with bamboo. There is no established ecosystem in the country. And this being a natural material and fairly tapering, different wearing diameters, different wearing thickness, different strength characteristics, one needs to handle the entire ecosystem. You can't leave it to chance. You can't leave it on someone else. So right from the getting the right material, where we worked with KONBAC for a very, very long time, sourcing of material, the treatment, the prefabrication, the straightening, the engineering, all of it. You've got to manage the entire thing. So a lot of magajmari, but one has to do it. Otherwise, there's no possibility. So only when you are able to get the right raw material. So on the left you see is the material that you get in mandi, and on the right is the raw material that we use. So till you bring that raw material right, till you are able to manage the ecosystem completely, it's not going to happen. So that's been the entire legacy. So this KONBAC started its work in 2002. Giants was established in 2016. There's been a whole journey, of learning, knowledge, time, energy, money spent to bring bamboo to where it is today. And this is just a tipping point. This is the beginning of a very, very long journey. So very quickly, I'll run through some of the products that we do and then come directly to the BRTC project just to give you a sense of what are the possibilities of bamboo. This is the entire interior done using bamboo completely, not a gram of wood used here. Coming to BRTC project, many of these images in some form or the other, Mr. Mayank has shared, so I'll not go through into detail, but I will like to share my experience as a contractor, as an agency which actually builds this entire structure. Mr. Ramarao always would say that we all can talk, but ultimately the onus is on the contractor, because if they don't build it, then everything else goes down the drain. So this first structure which Mayank shared, we, like any other construction, we decided we will bring the bamboo, treat it, and we'll do it at site. And we realized that it was just not possible. You need to bend this bamboo. So when one team would bend bamboo, and I would ask in the end of the day how many bamboo poles have been bent, and they would say just 2 poles. And I would scratch my head and think, 4 people bending one bamboo, and it takes 4 hours for one bamboo pole to be bent. How the hell am I going to complete this project? We require 226,000 running meter of 40 mm diameter and 68,000 running meter of 100 mm diameter. How it's going to be possible? So, and where is that level of skill available? That being able to replicate it. So, although we did this first structure at site, we found that we could achieve the quality, but it took a big, unexpected more time to do work. But as everyone had this mindset, this is the first trial structure, and all the learnings thereof can now be used to expedite the rest of the 8 structures that we are supposed to do. So with that mindset and these learnings, uh, the consistency that we were able to create in the first structure itself, etc., became an input for us when we build these structures, the next structures. So the next structure was the admin block, and here we said, let us start pre-engineering it. Let us start prefabricating it. And we started like you have a car assembly line. In a crude form, we started putting up assembly lines in the factory. Sanjeev, KONBAC worked together, and Sanjeev would share, I think, much more about the work that was done in factory. So I will just touch upon it. We invested in creating different, designed machinery to bend it, to be able to bend it faster, to be able to press the right amount of load, etc. Some of it was successful. Out of 10 experiments, 2 were successful, 8 were not successful. But slowly we could gather speed. And at one point of time, we had a peak of about 750, 800 people working in a factory site altogether, churning out large amount of prefabricated structures, something which you can actually transport. Although it became a big cost burden to us, because as an agency, we had not anticipated to prefabricate everything in factory and transport it by trailers and stuff like that. But we thought that at least that would save the time, otherwise it would just not be possible to do this structure. So then the speed started gathering faster, from 100 bamboo to 50 bamboo, different structures, staircases were designed, staircases could also be built, large spans could be put up, we use cranes for installation like you do for steel structures. Try to bring that element, as Dr. Abhay Gupta mentioned, of pre-engineering and pre-design and prefabrication that you try and apply to a steel structure. So with that, this thing got possible. We tried to say that 70 to 80% of the job we should do at factory, and only 20% of the job should remain at site. With that in mind, this is very interesting. My previous speakers have definitely shared, but I want to show you this image. This whole truss has been prefabricated into 3 parts, all in the factory, transported and assembled, and we are talking of like 380 truss full size. We're talking of more than 1,000 such trusses prefabricated in bamboo and shipped to site and installed. So when in a day we could install 6-7 trusses, that's when the blood used to run in our veins, and we used to feel, yeah, now it's going to be possible to do this project, within the expected time. And these were some of the challenges. Of course, there was a lot of interaction, because as we build structures, we faced issues, bending, buckling, the additional stiffness that would be required, etc., which Dr. Abhay Gupta has elaborated upon, and I'll not go into it a little more in detail. But all these things were taken care of when we started doing these structures. And I'll just share some pictures, which even Mike has shared, just to give you a sense of the size of the project. It's roughly about a 1 lakh square feet of built area, which was done. This is the hostel block. So in terms of basic learnings, which is what CE sir mentioned, that I should definitely, put that upon. Bamboo is not an easy material to work with as of now. Why? Because there is lack of knowledge about the material, lack of skilled manpower. It's not a very consistent material, and all these factors when you consider, and there's not a set ecosystem. But at the same time, the benefits of using this material, you can see, like where would you get to do a structure of 1 lakh square feet and say, look, we have been able to sequester 1,500 metric ton of CO2 from atmosphere just because we build bamboo structure. This is not going to be possible using any other material. So, there are pros and cons. And as architects, designer, client, I think one is, as Caesar mentioned, at least some part of it. If you may not be able to do some part, full, but at least some part of it, if you start doing in bamboo, then the ecosystem will start getting developed. Because when a person or a carpenter is working on bamboo joinery, he would say, okay, but where is this experience going to take me further? So let's say this big structure has been built, but are there any other structures of similar nature going to be built for me, to get that kind of a work consistently? Or I will end up coming and doing my typical carpentry. If I do that, then this experience is not going to help me at all. So it's a chicken and egg story, till you have the right resources and skilled manpower, you cannot do large construction. And till there are opportunities for construction, where will the manpower get created? Balance, that it's a tightrope walk, I think. At one point of time, if you see, there is an opportunity to able to give better livelihood. So when you take steel or concrete, for example, or cement, for example, at the bottom of the pyramid is a factory. Here at the bottom of the pyramid is a farmer. So if you see the entire supply chain, the amount of benefit that the entire supply chain gets in terms of livelihood opportunity is tremendously higher than that compared to steel and concrete. Also, like when we look at concrete structures, we say typically 60% will be the cost of material and 40% is the cost of manpower. But in bamboo, you will realize that probably 20% will become the cost of material and 80% will be the cost of labor. So what it means that more and more, livelihood opportunities are getting created, which for a country like ours is definitely a need of the hour. For this project, we had 15 months time and 3 months were extended, so 18 months. I think it's little higher than conventional material, but I also think that it is higher because it is being done for the first time. It is just like a car manufacturing. Once the assembly line is set and there is a modularity in design, there is a consistency of flow of material and fast as steel fabricated structure. That is definitely possible. In terms of raw material usage, this is very interesting. We tend to take 5-10%. Rolling margin in steel is not permitted more than 2.5%, if I'm not wrong. Because of the taper that Dr. Abhay Gupta mentioned about, from 100 mm to 80 mm, 70 mm, varying wall thickness. So a pole of 6.5 meter, the effective length that you get is only 4 meter. Where will the 2.5 meter go? So till you have multiple products, whether it is furniture or if you don't have structural requirement fence, simple fencing, till you have multiple of this, products as a combination, you will not be able to use raw material effectively, and it will be an extremely high wastage of 40 to 60%. So that's one factor that one is to keep in mind when you are looking at structures out of bamboo. The skill level is unique and high. Why I say unique? Because a small mistake will also be visible. When you do concrete, you plaster it and paint it. When you do steel, of course, you will again paint it, and steel, hardly there's bolting or welding. In woodwork, also, you tend to either cover it with sun mica or veneer or whatever. But in bamboo, even a scratch that you do would be visible because there's no way to cover it. So the worker who is actually working needs to have passion for his work. If he loves his work, then he will take care of it when he's doing the work, and that will show. So it's a very unique skill set required, and also a little high skilled. Because the joinery is different. You join using bamboo pegs. There is a certain level of skill required for that kind of job. And as I touched upon earlier, carbon sequestration is my biggest kick out of this work, is being able to contribute, to environment in whatever little way we can do, through the learnings of construction that I've had. So that's my biggest kick in the entire thing. So if you were to compare other impacts that are possible, in terms of livelihood creation, people trained, reduce inequality, the other, SDGs that the world measures itself, I think bamboo would be the hero material, in construction. So these are the kind of clients we have worked. We work in India, we work in Maldives predominantly, we work in Africa, we work for hospitality, institution, residential, etc. and got a few awards on this. And very interesting, I just want to share is this small picture of a work we did in Maldives, a restaurant for Waldorf Astoria Hilton, which has been recognized as the top 16 waterfront restaurants in the world by CNN UK. And the resort itself has been recognized as the top 5 resorts in the world. So when you do work with material like bamboo, you have opportunities to, to also stand apart in the crowd of other material that is used for construction. So thank you. That's what I would like to share in my brief 10 minutes, and thank you for this opportunity.
Thank you, Krunal Gandhi. Interesting. The last project which you showed of Maldives was also a very unique feature of the site. Site was like a blessed location. You had water body on all sides, but I think well exploited and very beautifully done by light bamboo structure. While you were presenting, you see there was one professor of botany from UP who was saying that bamboo being a grass can do such wonders, and he didn't know that it could become such a wonderful construction material. So I would like all the audiences to know that people other than architects and engineers are also joining in, and they are quite excited to know what bamboo can be expected to do. I think at the end of it, we have last 15-20 minutes. I request Karpe sir to add on your concluding part. You could say a few things about KONBAC. You should be also happy to know that a lot of excitement has been created already. And then we should take the question and answer session. There are very interesting questions that have been coming up. We'll take them one by one. So I request you to be, as a last speaker, take care of the time and begin your presentation. Welcome, Dr. Sanjeev Karpe.
Thank you very much, sir. I would like to take only 10 minutes. Uh, Basically, KONBAC is formed in 2004 with the idea of using locally available raw material. We have trained our farmers to grow this Tetracolmus toxis species of bamboo, which typically have 40 to 50 of a diameter and not more than 3 to 4 meter of a usable length. Uh, Even though this is not one of the best available construction material, uh, but when we refer to the IS code, we saw that if you do the proper grading of structural use bamboo, the first is about age. It should be 3 to 4 year age. Minimum diameter should be a 45 Then minimum diameter at top should not be more or less than 35 length should be 4 meter, taper should not be more than maximum 4 per meter length, straightness of the club should be there, and wall thickness should not be less than 10 So that is what requirement is. Now first, when you talk about age grading has to be done within first 1 week of harvesting. If you see this different age material, 1.5, 2, 3, 4, 5 year old bamboo of the same species, it look different. But after 2 weeks, when bamboo is dried, you will not able to recognize the age visually. That is the main limitation of a bamboo. And if you see how the age influence on the density and porosity of the bamboo, then for Dendrocolmus toxi, 3-year-old bamboo is the right material. Even if you see how shrinkage happens longitudinally, radially, tangentially, and volumetric, 3-year-old material is the best option for a species Dendrocolmus toxi. About the durability, yes, you need to treat bamboo. We have IS code for preservation of bamboo for structural purpose, and that code says that if you do a pressure treatment, the durability of bamboo will be 50 years. This is the typical pressure treatment plant which we erected in our Kudal CFC in 2007. Then you need to straighten the bamboo because bamboo pole is not always straight. So this is a very, very crude method of straightening it. This needs very high skilled manpower, but you can absolutely straighten bamboo like a pipe. In a similar manner, you can bend a bamboo. There are various methods to bend a bamboo, and you can really achieve a nice aesthetic looking bending. And once you have treated and graded bamboo, then you need to know that how much load it can take. So load testing is a must because bamboo is a bioresource. And after doing all these things, we started with constructing a bamboo cottages, typical with say maybe 6 meter span. And then we thought of doing a larger building with this smaller dia bamboo of a 40 to 50 dia. Initially, everybody thought that this is not the right material to do larger structures, but we said that because we have this bamboo locally available, we need to do it. When we did load testing, we found that it works. These are the component packs and through trailers on site, and then we tried for the bigger span building. Uh, and when BRDC project came, everybody said that now because this is a very big project, we need to have comparable material to international standards. So Bambusa bulka is one of the best species in India, which has been promoted in Maharashtra for a plantation, and a lot of planting is already happened. So everybody thought that now it's time that we should start using this material. So we selected this. This has a 70 to 100 mm dia having 5 to 6 meter of usable length, and you can get 2 or 3 pieces in one pole also. So this is the bamboo. Initially we procured it from West Bengal and treated in our plant, and then started making the components, and got confidence that yes, this can be bent also, and with a fair amount of uniformity, and we started prefabricating this in our factory at Kudal, and this prefabricated material has been used for BRTC. So yes, now in India we have the material which is comparable to international standards also, and can be used for construction. KONBAC is doing training for architects. Basically now new architect students need to be trained. So we have hands-on training workshop in Kudal, and young mind has been being trained. And I'm very sure that in the near future, we will have thousands of young architects working with this material. Thank you very much, sir. I will not take more of the time right now because we are already ready. Thank you, Rajuji.
Yes, sir. Thank you, Karpe sir. I think out of the several questions that have been coming, some of the very interesting questions are related to structural engineering about the vertical connectivity between bamboo. There is an architect called Makaran who has asked, when will bamboo as a material will be acceptable as a DASR material in the PWD structure so that the billing could be done as an option. And there was one specific question to Ramarao sir, can we build a bridge in bamboo as a pilot study, and whether we can do it. So I think Ramarao sir, you can say few things about it, though it is possible or not possible. I think you can highlight the bamboo bridge question.
Yes, sir. Yes, sir. Sir, despite all the challenges that I have narrated in my inaugural address, wonderful
Yes, sir.
efforts by all these consultants, construction engineers, and the contractors, PWD, and forest. All together, we have done a wonderful creation of this BRTC building. When we have created
Yes,
such a
sir.
wonderful building, why not we construct a bridge? So far, as of now, we
Yeah.
have not thought of any such bridge. But in future, yes, we may think of, and we can, because we'll be needing many more bridges in the forest areas. Probably, if it is,
Yeah.
as I said, if it is found beyond doubt that bamboo can be a substitute, definitely we'll be thinking of using bamboo bridges in the forest areas. Definitely, yes.
There was another question, sir. When will bamboo as a building material come in as a construction material for DSR? There is a district schedule of rates which PWD uses to sanction budgets. So when can bamboo find acceptability in a DSR as an accepted building material for billing
Sir,
and for using it as a construction material?
I think the chief engineer sir is capable and is competent to answer this. But what I feel is, when this bamboo is tested beyond doubt for all its capabilities and characteristics like RCC was tested, then it can be brought into the DSR. First of all, it should be put beyond doubt. It should be tested beyond doubt. Now we are just in a budding stage.
राजू
So
जी
you're
म्यूट है
mute.
आपका.
राजीव जी आपका म्यूट है.
Sorry, sorry. It got muted.
सी
There's
साहब को
another
आप सवाल
question
पूछ
for
सकते हैं.
Dr. Abhay. हाँ, सी साहब आ गए. थैंक यू देबडवार सर. देबडवार सर, तुम्हाला एक विशेष प्रश्न आहे. हॅलो, कॅन यू हिअर मी देबडवार सर?
Yes, sir. I'm trying to listen to you, but I will put my camera off because I'm not able to listen if I put the camera on. Please.
Oh, okay.
Yeah, tell
Sir,
me.
no problem. Okay.
Tell me, sir.
Sir, there is a specific question addressed to you. When will bamboo as a building material find acceptability in the DSR as schedule of rate?
Yes, sir.
For sanctioning of bills.
Yes, sir.
Yeah. So you would like to say something?
Right, sir. Definitely. In the coming DSR of 2020-21, we will include these items in the current schedule of rates of Maharashtra state. Yes, sir.
That's great. That is great. I think that is what was this. And this is also not part of the IS code.
So that the different organization can start using those items in their estimates.
Yes. So for DSR issues in Maharashtra, it will start coming in next time. Okay, in the next session.
Yes, sir.
So there's another question. What are the impact of earthquake on bamboo structure? Was any question asked to you as a PWD engineer?
So this question was not asked earlier, but you see, when the structures are designed, what is needed in the earth to cater for the earthwork is the whatever forces, tensions, and torsions are developed because of the earthquake. Those are to be considered in the design. Once we accept bamboo as a material to be used for the columns and beams, naturally it will be useful even in the earthquake zones. But we have to appropriately design that. That's it. But the answer is yes.
Oh, thank you, sir. Thank you very much.
Thank you, sir.
There is another question to Dr. Abhay Gupta. Where does bamboo find its mention in IS codes, BIS codes? And what are the opportunities for any structural engineer to work out the details of joinery vertically in bamboo? It's all right horizontally, but because of the tear up share of bamboo, how do you do vertical joints in bamboo? He wants you to respond, Dr. Abhay Gupta.
Mention of bamboo in IS code, there is a whole IS code on the bamboo construction, design and construction. Already shown. IS 15912 is there, and it is already passed through one amendment. There is a second version, so it is already on a developed stage, that code. As far as joining is concerned in the vertical, in this project we have designed length extension joints of bamboo, that is by using a sleeve in the bamboo hollow space and then connecting that with the and designing those bolts for the shear on the tensile force. What is the tension coming? Secondly, we have also used connection design for the bending as well as for the shear, but there we have used MS plates between the bamboo, and then the bamboo is connected to each other through that MS plate. That is the methodology we have adopted. Though our experience and other experienced people also say that in bamboo it is good to use truss structure where the compression is developed rather than bending, because the bending connections, that rigidity and the control of the rotation over the joints may not be as good. So in our analysis, at several joints we have not considered them to be rigid joints. Depending on the placement, several members we have considered to be pin connected at the ends. That is how we have used.
There are another two questions for you from architecture students, sir. It says that what is the life of a bamboo structure if built? What is the maximum span to which bamboo can be stretched? And third, is there any dampness caused because bamboo structures are seen always in an area where there is heavy rainfall? So, can bamboo structure prevent dampness to the interiors? Like you have bamboo furniture, but can dampness be avoided if bamboo structures are made? So, this is also addressed to Negandhi sir, who actually implemented the project. So, either Dr. Gupta and Dr. Negandhi can take the questions one by one. Yeah.
Third question, Kunal and Mayank can take. The first two. First was, can you repeat the
Yes.
first question?
What is the life of the bamboo structure? How long can it survive?
See, it can,
Since bamboo is
as far
also
as,
designed for earthquake resistance. Yeah.
yes. So as far as life is concerned, it can be designed for longer life, but in this structure, we have taken 25 years of design life of the structure.
Okay. All right. Second
Secondly,
was
yeah, please.
second was dampness in a structure.
Dampness, I'll
Whether
to Mayank and Kunalji.
Yeah.
okay,
But the third one,
Mayank,
earthquake and wind, we have taken full
care.
as per the application, and we have designed members as well as the joints for that. One more question over there: what can be the maximum stretch of length to width?
Span, yeah.
As such, we have not kept any limitation in this project. Probably we have gone up to 11.5 meter, but there we have to make a truss. There is a thing.
And the length to the width ratio, does bamboo affect the ratio between the length and width of the structure?
No. We did
Length
bunching.
and breadth of the structure. Yeah.
Okay. No, nothing.
So no
we
problem.
did bunching. No problem.
Right.
Up to 50, 60 bamboo in a bunch we have used.
Okay.
Dampness and Mayank can.
Yes, dampness. I think Mayank and Negandhi can answer.
Just to add to the life of the structure, bamboo, the good thing about this material is it is replaceable, which means after 25 years, if you find, or in middle of the time, if you find that there after 12 years you find that some structural members are behaving in different manner, you can replace that element and still have the structure in place. So the bamboo life can be increased to as much years as you want. The architect in Vietnam, Wong Trong, actually designs his structure in a way that every structural element of the bamboo can be replaced with a new member. So the life becomes forever. That is one of the ways. In earthquake, in cyclone, and in various other aspects, we have felt that bamboo behaves much better than as compared to the rigid structures like concrete, because the joints allows those kind of movements and can absorb all of these. For dampness, it is important to design structures where bamboo doesn't always remain in damp area, because it can then have a lot of damages to the bamboo's strength. So it's important that you design bamboo structures in a way that where it's not inside water for a longer period of time. So the details that you will see in BRTC projects, after the foundation, after the plinth level, the bamboo structure starts over that.
Okay.
I think Krunal would also like to
I
add.
will, I will
Yeah, Krunal. Yes.
So, in terms of life, there are two things. First is the life of bamboo itself. So, the method of treatment which has been used in this project is called vacuum pressure treatment, and this method of treatment has been invented by Forest Research Institute Dehradun, and the first structure which they developed after using this treated bamboo has been way back in 1956. Until today, the structure stands completely intact. So it is said that the life of bamboo itself per se is 50 years in external conditions and 100 years in internal conditions. Then comes the life of the structure, which depends upon taken into cognizance, the different loading factors, and most important, the creep, the effect of creep on the structure. And that, as mentioned, that in case, in the eventuality that even if there is something, one of the components that get higher modulus, it can always be replaced. So that again, life of the structure is, I would say, nothing less than 30 50 years. In terms of water dampness, the example that was given is, you see a lot of it in the northeastern areas, because bamboo growth, likes water. So either relative humidity in the atmosphere, or good quantity of water for irrigation. That's why you see a lot of bamboo naturally growing in those areas. As far as the structures are concerned, if you can, to an extent possible, prevent continuous onslaught of rain, you know then the life of the structure will be as much as 30, 40, 50 years, not a problem. But if you have continuous exposure of bamboo to rain, or in complete damp areas, then you have to take certain precautions to it. That's about it. So that has to be factored in the design accordingly.
So next question is for Ramarao sir. There is a group of architecture students asking, sir, what is the best time to visit your institute in the month of April, May during our vacation? And whether we will be able to attend any certificate courses of use of bamboo construction as a material. We are
Yes,
fourth
yes.
year and final year architecture students. Can you give internship to architecture students in your institute?
Yes. They can contact Mr. Rahul Patil. He is the director
Yes.
BRTC. He is stationed at Chandrapur, and we have a 70 days course, and we have a 2 years diploma course. And if you contact him, and he will be able to tell you the details.
Yeah, they are interested in something like 2-month course, whether accommodation would be available, and is it okay for
Yes,
them
yes,
to come? Okay.
yes, yes,
So
yes, yes,
this was
yes,
this was
yes.
their concern. They want
Yes,
to
we can.
come to your institute, sir. Yeah, and
If
work
they,
with their hands.
sir, if they come in next April, by the time the hostel box also, the hostel blocks also will be ready, and we'll be able to accommodate them there also. Because
Okay.
this project has two hostel blocks also, one for women and one for men also. So that
Okay.
can
I think that
that meant for these kinds of visitors only. Otherwise, we have a full-fledged forest restaurants also. We can accommodate them. Sir, I have a small question to Dr. Abhay Gupta, sir. Can I ask?
yes, sir. Yes, sir. Please, please.
Sir, these present bamboo structures are being designed for very small, less superimposed loads apart from its self-light. Can we think of, or can the present technology accommodate for more superimposed loads, or whether the IS 15912 accommodate for more superimposed loads as other IS 456 and 800 accommodates?
Sir, we have designed this entire structure as per IS 875 Part 2. All prescribed
Oh,
loadings are
okay,
used
okay.
in structures as per IS 456 or 800. Same office loading, etc. has been used here.
No, sir. My question
Okay,
is,
okay.
the present bamboo designs are such a way that very less superimposed load, only self-weight, some little bit superimposed load, not designed for more
Full
superimposed loads.
load is there.
Can we think of having more superimposed load?
Yes. We have taken full superimposed load prescribed in IS code. Institutional superimposed load. Yes.
No. My question is, the present design of bamboo structures are to have a minimum superimposed load. My present question is, can we think of having more superimposed loads like we have it in RCC or steel structures as per the present technologies available? That's what I'm saying.
Yes, we can.
Okay, that's the answer. Okay, thank you, sir.
Mute है राजीव जी mute है.
So the next construction is related to the diameter of the dome. What is the maximum diameter of the dome that the bamboo will be able to sustain as a building material? Will 90 meter be enough? Will 100 meter be enough for a dome, or will it crash if we increase the diameter to more than 100 meters? In short, what is the strength of bamboo if we increase the diameter of the dome construction?
We have the experience of up to 90 meter. So beyond 90, whether what bamboo is available, what will be the behavior is not experienced. I am sure that it should not have any issue.
So
Okay,
in
it can extend.
Shanghai,
Yeah.
yeah, in
Yeah.
Shanghai, the Indian pavilion was 35 meters diadome, uh,
Okay.
which was by use of Moso bamboo. It can go up to 90 meters also, depending on the dia and the structural design. So
Okay.
this we
Okay.
feel we can go up to 90 meters also.
Yeah. Yeah, I think most of the other questions have been answered. They have been asked in some form or the other. We have two, three people from West Bengal Institute of Biological Sciences who found this presentation so interesting that some of them are going to promote it as a building construction material to biology students and botany students, which I find very interesting. There are a few engineer students from Ahmedabad who are asking, can it work in desert atmospheres or dry atmospheres where the climate is hot and dry, like in Kutch or like in the deserts of Jaisalmer and Rajasthan? Because now that it has been found working in northeast and areas which are wet and warm, will it work in deserted zones like Kutch? Will it work? Because they want to have structures built like this for smaller health centers or for smaller institutes or schools. Will it be safe to do that? Because they are interested in building primary schools in bamboo construction. And how will the government respond to it? Will anybody tell them that if you build a bamboo structure for primary school, it is okay to do that? Something like this.
Sir, may I answer?
Yes, sir.
So, if you want to build in desert, selection of a species need to be very, very careful. There are few species which has a less tendency to crack, which has a very good wall thickness, diameter to wall thickness ratio. So yes, we can do construction desert also.
Okay.
Somebody asked a question that can we use a dendrocolumnus strictus? Yes, we
Yeah.
can use dendrocolumnus strictus because the strength
Okay.
is higher. Only thing is, look, if you are okay with shabby looks, no, dendrocolumnus strictus doesn't look so good. So depending upon what type of aesthetics you want, you can definitely use it. There are 16 species of commercial importance which can be used for construction, which are being mentioned in IS code. So we can use any of that 16 species for a construction.
Yeah, thank you. Thank you. I think there is one question for Gande sir. Gande sir, are you there? Hello, Gande sir. Will Tata Trust be open to funding other institutes if we approach them on the lines of the one done at Chandrapur? And whom should we approach? Can we approach you directly, or what are the best ways? This is from Gujarat and Rajasthan, sir.
Yeah, so the immediate response is this is one off type of activity for us because our regular projects are for promoting cultivation, utilization of bamboo across different sectors. So we are just waiting to see this big structure completed, and definitely in the future we'll take a call on this. So the short answer is definitely not denying it, but we will take a wait and watch approach to see how this structure stands up, at least for a year, and then we can proceed further.
Yeah, no, but their question is, sir, can they contact you directly or should they contact KONBAC, or how can we approach Tata Trust? What would be the best way to do it?
It is either way. They can come through Conback, they can come directly, no issue.
Okay,
Yeah,
okay,
but
okay.
if
I'll.
expecting something immediately flowing in, that may not happen.
Okay, sir.
Yeah,
It has
the
been.
other
It
part
has
of the
been.
other part of it is the trust is not exclusively devoted to bamboo. There are other priorities also. So it is a competitive demand always. So that's why it is both yes and no, depending on the exact situation.
No, sir. They were asking because they are doing some military constructions already, and if they can use bamboo as a special material, it would help them do structures faster. Looking at our example, is what they wanted to know. So
Yeah,
will you be open to funding works on defense zones or defense areas?
it is. We don't categorize into defense or non-defense
Okay.
area. We have
Okay,
in
sir.
quite a lot of areas working directly with army also.
Okay,
So
sir.
one of
Okay.
the best advice which I can give to them is if they can source some funding from the Sadbhavna project of army, which is a CSR
Okay.
project, and it is exclusively devoted to infrastructure development. So if they
Yeah,
are working
I
with
hope
establishment,
they are listening to you. They are online actually.
yeah, yeah, they should be
But
taking a clue from this.
sir, there it is 5:21. We have exceeded our time limit. There are many questions still unanswered. I am going to tell everybody a big thank you for being with us for last 2 hours. I would request all the participants who have joined us to get in touch with KONBAC. They can also get in touch with the principal of Sir JJ College of Architecture. Like Abhay Gandhi sir just said, look at the opportunities also available. Otherwise, I would like to thank Dr. Abhay Gupta, Dr. Kunal Negandhi, Mayank Mishra, Ramarao sir, Sanjeev Karpe, Abhay Gandhi sir for their invaluable time and making their presentation and also patiently asking me to let them know how to answer their questions for you. It has been a wonderful learning process. I think we all enjoyed by understanding bamboo, which is a botanical grass in terms of a botanist, but a very strong structural material which was lying unutilized because of not being aware of its strength. Today, I think the structural engineer, professor, and the structural consultant have verified, have given it for sure, understanding that it can be used very safely as a successful building material. Thank you, Mayank, for a wonderful presentation. We thank Sanjay Prakash to let you do it for us. Say hello to Sanjay Prakash and thank him.
Yes, sir.
We will be very happy. We will be very happy to welcome Sanjeev Karpeji to JJ College of Architecture after this COVID-19 pandemic is over to actually construct one small workshop with us for the full day where students of our college get a full hand-on experience to work on bamboo cutting, bamboo fixing, bamboo joining. And I would request Negandhi sir to join us. Ramarao sir will love you because you are an Indian forest officer with a specialization in structural engineering. It will be wonderful to have you one day in JJ College of Architecture, which is the greenest campus in the city, and you will love our campus. I
Okay,
request
sir.
Gandhi sir, Gupta sir, Negandhi sir to please come to our campus, interact with our students. And I thank you all for your time, for your question and answer session. Yes, Dr. Gupta, you would like to say something?
Thank you very much. It was a wonderful
Dr.
session.
Abhay Gupta and
And you
Dr.
moderated well.
Okay, so with your permission, I thank all and I declare the webinar closed. Any questions, any further queries may be addressed to KONBAC and to Sir JJ College of Architecture. Our email address is asirjjcoa@gmail.com. A for Apple, Sir JJ, College of Architecture is coa@gmail.com. KONBAC has got a website. We also have a website. Please address all your questions there, including all the participants otherwise, and we will get back to you at our earliest. I would also like to give special thanks to Sanjeev Karpe for all his support that he gave us for organizing this webinar successfully. Thank you, Konback. Thank you, Sanjeev Karpe. And thank you all.
Thank you.
Thank you to all the
Thank you.
Thank you
audiences for
very
being with
much.
us.
Thank you. Thank
It
you.
was,
Thank you, sir.
it was a
Okay,
great
thank
session.
you.
Thank you.
Bye.
Thank you, sir.